Excellent. Welcome back, everyone. Lines have been connected, people have dialed in, and unlike other conversations that will happen in the US this evening, microphones will not be automatically muted after a set period of time. So this is the Data Federation with GraphQL panel conversation. We know that data is everywhere, and we know that data access can be a bottleneck. And we know that the best way to understand this problem space, as Tanmai described earlier, is to talk to people about how they reconcile the challenges. So that's what we have, an amazing panel. We're going to start with BG on the panel, who's part of the Silicon Valley venture firm 8VC, a partner and CTO there. As I mentioned at the top, we asked for interesting things from everyone. BG actually sent us quite an interesting thing. Like in the time of COVID, there's been a lot of focus on organizing remote music performances for his nonprofit, which is super exciting, and recommends that if you have the opportunity, that you take time to discover the genius of the American songwriter and singer John Prine. Also on the panel, we have Diana. Diana is a front-end engineer with Uber, with a focus on designing interface for emotion, which may be one of the most beautiful descriptions in a bio I've read in a long time. Interesting facts include how much weight as a human is capable of being deadlifted by her, which is impressive. Desire to head back to the office, and a recommendation for Zat Rana. Deep is joining us as well, a product leader and customer advocate, currently working at SAP. Extensive experience in building rich business technology platforms. You will see in a moment that Tanmai is on the panel as well. And last but absolutely not least, no conversation would be complete without a skilled and talented moderator, a person who I am delighted to call a colleague, Allison, who was, it turns out, the captain of the chocolate club at MIT. Allison, go ahead and take it away.
Awesome. Yeah. Thanks everyone for being here. And let's just jump right in. So let's start off with, what do we mean by data federation? What does data federation mean to you? What key features should it provide? And what does it mean in the context of what you're working on? Let's start with Diana.
Sure. So first of all, I think I'm a front-end engineer, so I deal a lot with Apollo, which is implementation for GraphQL, a client and a server side. And they sort of monopolize this term as implementation for a particular data federation kind of implementation. Although for me, data federation is really just a single point of entry into a distributed system. And that's exactly what it should provide. It should provide a single point of entry, and it should be distributed in a way that is deployed, organized, and distributed.
Very cool. BG, what does data federation mean to you?
By the way, thanks for having me on the panel, Tanmai and team. Data federation, given that I'm the only non-engineer and the non-product builder on this panel, data federation has been a theme that has persisted for a long time, from first, second generation databases all the way to data lakes now. And right now, I would say on the online operational side, if you look at movements like Hasura and GraphQL, building online applications with access to many different sources of data at the same time, and with a common unified metadata tier and interface, while also optimizing for performance, is kind of an important track in building richer and richer applications. What does it mean? Ultimately, it's about interoperability and the ability to talk to different disparate sources of data without having to control them completely. So it's about decentralized development of applications.
All right, Tanmai.
Yeah, just to kind of pick up from where PG left off, right? I think like when I think about data federation, right? I think the kind of most important aspect for like federation at whatever level you do it, right? When you think about like API federation, which is like you're bringing in APIs into kind of a unified gateway? Are you thinking about bringing in data from multiple sources into a single endpoint, kind of like BG was talking about, right? And so I think that the thing that it should solve, right, is that it should federation is that the fact is that the owners of data are going to be different people and different teams, right? And somehow being able to give those owners of data enough control, but not make them a bottleneck, so that when application developers who are across kind of team boundaries or organization boundaries want to access data, that is easy, right? There is a data democracy, for example, right, has to be enabled by federation, right? So when we say that people should be able to kind of access data, but at the same time, anybody should be able to access data, but governance and security should be taken care of. Data owners should be confident about saying that you can take access to data, right? So that I think is that I think is what federation kind of should solve, and what federation means for me, right? And however we implement it, GraphQL provides an opportunity to think about that problem, whether we do it via GraphQL federation or data federation, then expose a GraphQL API. But that's kind of what federation means to me.
All right, and Deep, what does federation mean to you?
Yeah, I'm looking this from the enterprise world, right? I mean, I think mostly Tanmai and BG has already, explained it. I'll just bring in my perspective, right? I mean, if I look at the problem today, right, customers has got completely heterogeneous systems, right? There are multiple systems, that sources of data that they are talking to, and then the idea is, or let's say, the principle is that all these sources, even though they are heterogeneous in nature, retrieving data or communicating with them should be seamless. And then you must add a layer of governance on top of it, have a good secure mechanism so that all the data that you're accessing is completely secured. And in the end, and the whole idea is that even though the data is scattered across multiple systems, right, you would want one state of that data to be present along the systems as well. So one unified state, right, that is very important when it comes to data federation, right? And then, of course, the access layer, the governance, and the sync part as well.
Awesome. All right. So drilling down just a little bit, what specifically have you done with federation, with or without GraphQL? What are some of the tactics that you've used and the challenges that you've faced? Diana, you want to lead us off?
Well, to be honest, from the biggest challenge I feel right now, at least at the space where I am, that there is no data federation. The challenge is, how do you actually build this data federation in like ideal way? And kind of just to bring a bit of a background to, I work for Uber, and the company sort of went through like this hyper growth stage, and we went from like 2 services that were like driver and rider side, and then to allow to grow the engineering organization and all the other good things that comes with growth, we sort of scaled our, like, not me, but like the company scaled our organization to like, right now it's above 2,000 microservices. So this is, and this like enabled great things, to be honest. Like the company wouldn't be there where it is right now without this opportunity, or like this kind of distribution of functionality into separate services, also like the team kind of ownership models, deployment, all these things being allowed by microservices. But I think now, since the company sort of has grown up, like right now, the problem at the engineering organization is whenever you need to introduce new features or you are continuing some development, there's no useful kind of abstraction layer above those microservices. So if you really are, like, you really need to understand more or less nitty-gritty details of a lot of kind of data flows to be able to navigate or build like anything really. So data federation, so to answer your question, the biggest challenge is to actually introduce this data federation, which is scalable and sort of answers all of those requirements that folks on the panel mentioned. And just to build it up, that's the biggest challenge, at least for the company I'm in right now.
If I can sneak in a question, Diana, I was super curious as to what are the 1,000 microservices is insane, right? Like what are the do they all have like different protocols and ways of speaking? Like how do they what are they like all like gRPC and HTTP, or what is it like? Or is it like many different things and different teams have different APIs and protocols?
Right. So I think like historically they used quite a few protocols in between. So right now they historically you probably find like Thrift, which is like actually older version of Thrift released by Facebook. We have some microservices communicating in REST still, which is very rare, but the company standardized on gRPC, Proto over gRPC. And this is a sort of commitment by engineering organization. So any new services that are built using this protocol, and we are migrating the existing ones to the Proto.
Got it.
All right. So the goal is kind of composition and with an end goal of really scalability. So that's really cool. BG, how about you? What are the challenges and what have you done so far with data federation, GraphQL or otherwise?
Whenever I'm asked a question, Tanmai is breaking out in peals of laughter. So let me try to keep this serious, guys. As you guys probably know, I'm a VC and an investor, so I don't write code anymore. But data federation has been, it was fun back in the beginning of my career. We did a fair amount of work at Oracle around federated queries. Like there was a notion of a gateway. So the interesting thing, if you look at the architecture of how we did it at Oracle, it would be good for anybody working on data federation now to go back and read some really classic papers from IBM on a system called Garlic. So I would highly recommend. So the interesting thing I noticed, I was just digging into Presto last night. I was talking to Tanmai a lot in the last week, is the layered architecture is very similar, that you will ultimately be pushing, you'll need like wrappers around all the sources. Then you'll need some sort of mediation tier. You need to expose some sort of unified object model on top. And at runtime, you'll try to do as much query optimization as possible, right? These are kind of the 4 building blocks of, and somewhere you'll need to take care of access control and security and stuff. In the case of Oracle, the access control security, if I remember correctly, was done in a layer called the Oracle Gateway. So this was, back when Sybase, Oracle, Informix, IBM DB2 all had to support federated queries because data was growing in the enterprise across disparate sources. And then I would say on the offline analytics side, Presto has done a great job. So federated queries are also becoming extremely popular around data lakes, right? You can have your data in blob stores, in a columnar store, like at least at Facebook, they had a columnar store called Vertica. Then you can have a cloud warehouse like Snowflake. And without letting the owners relinquish control, you'll ultimately do the same layered architecture. Whether your query engine looks like Spark or MapReduce is a separate thing. And now, we have come back to what Tanmai and his group are working on, which is providing the same functionality and more or less the same layered architecture for online data. So this is kind of a great convergence happening. And I would say, to me, the most fascinating point is, I would say the 80% similarity in the end-to-end architecture being built, in the data models coming in. That's what I would say. In terms of examples, one of our portfolio companies that actually Hasura works closely with, which has built a cloud-native SQL database called Yugabyte, they are beginning to see many use cases of the sort that Hasura is seeing, that when you're building an application, you might be doing live callouts to other microservice APIs, to a third-party API like Square or PayPal or Stripe, bring back data, and then actually maybe even read some other online SQL databases and finally do a write back into your kind of source of truth database. And I would say that's been exciting, that the kind of the data diversity and system diversity on the online side, and seeing that Yugabyte is ultimately also becoming the backend for these distributed federated cases has been exciting. Anyway, hope you guys enjoyed that brief snippet of history there. Back to you.
And I think to one of the things that's like super interesting about this was, right, like when Diana was kind of talking about like there's this microservice explosion, and they're exposing kind of APIs and essentially data with stored procedures, right? Like data models and things about those data models or actions on those data models, which are represented in the APIs, and which is kind of like at the and the problem that Diana also, if I understood right, Diana, was kind of like the API unification problem, right? Which is like there's so many of them. How do we get those APIs, right? And historically, we've seen a similar problem that you were talking about, Vijay, which is kind of like this data federation problem, which is more of the like which is kind of like the databases themselves being queried, right? And I think like I had two quick questions for both of you, right? Which is Diana, what is the story with that today? Like, is there a GraphQL layer that is being built at Uber that you're building that is connecting to these services, that is providing that unified API, but then kind of largely proxying to these upstream services and not doing what is that API unification story like today? How is that being looked at today?
Correct. Yeah. So exactly, pretty much what you described. So we have this like quite a big number of microservices at Uber, and GraphQL currently being sort of, approved as a technology or like the go-to way to do the client to service communication at Uber. So it mostly currently driven by front-end teams who like build up this layer of it's a kind of like presentation layer, very thin GraphQL layer that like connects those APIs into like reasonable data model. And we're using GraphQL for that. Although on the back end and on the sort of like down the stack or up the stack, we still dealing with the same sort of like the picture of mainly protobuf over gRPC situation.
Got it. Makes sense. And Allison, my apologies. I'm going to sneak in one more question because I was super curious, which is, BG, when you talked about like the database kind of federation stuff, right? Like how was governance and like authorization? What were people thinking about when they were thinking about like policy, like governance policies or authorization, and how are they federating that part of it, right? Which is like, we'll have a data gateway, but then does this data gateway have like full unprivileged access to every single system there? Or like or did it integrate with the database security mechanisms of the system that was being queried?
Okay, before I answer the question, there's an interesting part that came to my mind as I was listening to you guys. I think one of the things you guys should watch out for is the examples I gave, whether it was for Oracle Garlic and then, Presto. These are all more like analytics side, right? So ultimately the systems you build there are more for throughput, not for latency. What is interesting about what you guys are doing now and what I'm seeing through Yugabyte is when you're making live applications work, so there's you are actually building more OLTP and online systems, and you'll probably be optimizing your systems more for latency. So I'll just leave that as an interesting exercise to think about. I think, so governance and security models, I don't remember it that well, but it was fairly simple. Essentially, if you were writing a federated query in Oracle, and one of your remote databases was an IBM DB2 instance, another one was, say, a Sybase instance, it was whatever the administrators of that database had given you access to.
Yeah.
Fair enough?
Got it.
So there would be a two-level kind of blocking and tackling happening. One is the federation gateway on the Oracle side, so you can think of it as the consumer side. But when you're actually getting routed to the IBM instance somewhere, there is a security checking happening there, right? But I think in my mind, we didn't need to redefine security for federation, because it was not like you were querying 17 live sources at the same time. I just have a feeling that what you guys are now trying to do on the online side, whether that you're doing live querying across microservices, third-party APIs, and on-site online DBs, requires a bit more structured look around security, as I pointed out, around latency optimization for your runtime. Third is, I think, one of the harder parts that we haven't talked about yet, maybe we can talk about it later, Tanmai, is about the overall operability of the system. Like if you start, because you're adding a lot of point complexity by adding more and more sources and more and more event-driven logic on top, right? So I don't have a profound answer for you around the security side, except it was not a lot more different than what database governance and security was. But I think that story now has to be a bit more structured and complicated. That's my guess.
Interesting. Yeah, makes sense. Thanks.
Yeah, that's a lot of really good context. Again, Deep, how does this align with your experience?
Well, data federation, right? I mean, as BG mentioned, I mean, this problem has been there for a couple of years, right? I mean, at least for the last 20 years, right? Things have changed with the cloud, systems coming into the picture. This was very prevalent on the on-premise world, right? But now with the cloud, things are quite different. But the problem still remains the same, and the solution is also the same, right? You would need a stacked up architecture, right, in order to solve this problem. And a middleware layer is what the approach has been previously, and today also it's the same almost, right? So I mean, if you imagine a sort of a pyramid structure, right, at the bottom of the pyramid you would see your different data sources, right? This could be your DB, right? In SAP world, this is the HANA DB, and then there are other products as well, which is the ERP, the CRM system, and all the other Aribas of the world, right? And then on top of that we have the middleware, and then this middleware is the place where all the integration logics comes into picture, right? Whether you want to integrate with a system, right? I mean, this is the place where you write your logic, you do all your federation, right? And then in the end, all you want to do is you want to expose this outside, for the outside world to consume, and that's where the API layer comes into picture, which is what we call the enterprise API fabric, right? And the protocols change, right? I mean, the protocols could be REST, this could be GraphQL, right? I mean, the protocols are not a problem, but then this layer, the API fabric, is the layer where the outside world is going to actually communicate, right? And all the security, all the access control, all the logic, right, where you can do the federation for only on the API layer itself, right? You can directly put it within the fabric itself, and therefore this fabric becomes the new gateway on the cloud as well. So if you see, right, it's the same architecture what it used to be 20 years back. Just the difference is that who maintains the software and who maintains this, that is all that has changed, but rest most of the things are same as well.
Yeah, and that's a great segue into kind of another thing I wanted to ask about. So the who is also a really key factor, not just the technology. So can you say a little bit about how, as an organization, on an organizational level, you're looking at discoverability and responsibility for all of these different data sources and the coordination involved? Deep, you want to take this one first?
Yeah, sure. I mean, as I said, right, I mean, that's one of the key challenges when it comes to data federation, right? I mean, one is like the governance and the security aspect. What do you govern, and who do you give the kind of responsibility, right? But then, I mean, this major part happens within the middleware and some part within the enterprise API fabric as well, right? I mean, if you are really looking to connect two different systems with two completely different protocols, right? Let's say HTTP with AMQP or MQTT, right? In such cases, all this governance and everything happens within the middleware, within the integration layer itself, where you just come in, you add your system, right, and then whatever you add your system with the necessary protocols, right? I mean, this could be OAuth, this could be your FAN credentials, so however you want to communicate with the backend system, right? And then you just expose it through the API layer, really. And then if you want to have the mechanisms, or let's say an API key, right, or other sort of mechanism control the API itself, you take the API fabric layer where you mention, or let's say, you modify whatever your business logic or your business rules comes into the picture, right? And that's the place where you would actually want to play in. And that's where actually the whole federation topic comes into the whole ecosystem.
Okay, cool. Diana, what's your experience with discoverability versus responsibility for federated data?
Right. So I think this is a key component that from my perspective, microservices introduced is this clear separation of ownership. It was very easy to define that the team owns this microservice and this team owns this microservice. They own their own model. There's some communication in between microservices, but there is no really overlap in who deploys things. Now it's by definition, it's the graph or data federation should introduce some kind of interconnection between those. And as their things become tricky, especially in a big organization, it's a fundamental shift in how things are organized. And what I am in particular excited about GraphQL in this regard is that it allows for this ownership model to be built into the schema. There is a way to there's just a simple kind of language allows type extension and things like that, but just that the fact that this particular type is owned by this, for example, team, and it should be on call for the resolvers is part of the schema, and that what makes this GraphQL story very appealing to me, as opposed to protobuf. And I'm this is the struggle that I'm trying to be tiptoe around, because if you start to do protobuf versus GraphQL, it's really a no starter in terms of a conversation. So I think what would be the most interesting and the most kind of productive way to approach it is to how do we make them kind of play nicely with one another. That we don't want to replace the whole kind of the stack with GraphQL. And by we, I mean front-end engineers who are super excited about GraphQL. But we do see the benefits that the capability of the language provide, that we think protobuf should pay people on the back end who really hardcore of HTTP2, and they just if you say JSON, they just hang up on you kind of thing. They should just be a bit more curious about it. So that's where I feel work should come in.
That's
Tanmai, I see lots and lots of enthusiastic nodding and laughter.
Yeah, I was I loved how Diana is the if you say JSON, they're just hang up the phone, cut the call, leave meeting, end meeting for all. We are not dealing with JSON, right? So yeah, I think this is building off what the others have kind of said, right? Which is that I think when we think about I think we need to move to a world when we think about federation, right? We need to move to a world where discoverability is kind of automated. So you can, right? Almost I think there's a rise that is happening because there's so much explosion of data, right? There's this data catalog, data dictionary stuff that is happening all over the world, right? And it's largely still it's more prominent on the OLAP side than the OLTP side, but we need a version of that, right? And that has to be automated. Nobody should have to maintain that. It should just get maintained, right? Which is the discoverability aspect, right? So teams still get to do their thing, and that maintenance kind of happens, right? And the important thing is when we think about the responsibility of the responsibility of maintaining the data, whether it's presented directly as data or whether it's presented as an API, right? And how is that responsibility going to who maintains that? I think is and how they maintain that is obviously a part of it is with the team itself, right? But there is a contract. There is this automated contract that needs to happen somehow, right? So that, like Diana said, there's the folks who are publishing this are publishing over protobuf, but the folks who want to consume over GraphQL, right? So And there is obviously an impedance mismatch that's going to happen, right, between these two systems, right? So who's responsible for making sure that there is no impedance mismatch, right? That's a harder question to answer, right? And then when it comes to like other aspects of responsibility, like authorization, you can think of authorization in both ways, right? Which is that the publishers and owners of data obviously present a degree, they handle a degree of that authorization and security, that aspect of like the responsibility, right? They handle that to a degree, right? But then there is a degree of kind of centralized governance also, which is why you have a central gateway, right? Which is saying that, if a particular, like if admins access, they should be able to access everything, right? As everything as defined by the data owners. If users access it, they should have this. If there's GDPR, this is how it should be done. If there's PHI compliance, this is how it should be done. Now that is that kind of almost has to happen at this central layer, right? That cannot be pushed down because that is common across everybody. I mean, or maybe it can be pushed down if the aspects are usable. So I think there are certain elements of, I think, security that are the responsibility of security that are split between this thing that will get everything together and the thing that is publishing data, right? Apart from the kind of technical problem, there's also like a process thing, right? There's a decision of like, okay, some centralized governance will happen here, and then decentralized governance will happen because obviously the teams will decide what they want to expose, right? If they don't want to expose everything, they won't. They will have APIs to control what they expose, right? Which makes sense. So I think I did not answer this question, but my view is that I think discovery should be automated, and there is a control that you need. There is a degree of control that you need at the gateway to maintain some responsibility. I don't think all responsibility can be entirely federated. I think some responsibility has to be done at the thing that's bringing things together. And somebody has to set that up. Somebody has to configure that, right? Somebody has to either build this gateway or configure this gateway and put some stuff here. It seems hard. Like I haven't understood how control can be federated. Data can be, but like control is harder to understand. Does that make sense? Those are my thoughts.
Awesome.
Yeah.
And sorry, Diana, go ahead.
Yeah, I think that's exactly right. So when you view this architecture as microservices kind of distributed and there's like a common single layer, I think the organization should follow this in terms of the team structure. So I think the most kind of viable implementation of such architecture, I think, is there a single team that like sort of pioneers this layer. Then the kind of the details and implementation can be distributed, but the bootstrap of this has to be done by a single kind of government entity. And that's exactly kind of like the organizational problem that should follow the architecture.
Yeah. I think that's
maybe a quick comment from my end, right? I mean, we see this day in and day out with enterprise customers as well, right? Where they want to govern with a completely centralized team, right?
Correct.
So
Correct.
The owners, let's say, let's say the technical job, right, for a developer is just to write that beautiful piece of code, and then create an integration or an event, right, and then in the end create an API. But then how that API is going to be used by the outside world is completely dictated by this central team, right? And then, I mean, today we have different mechanisms, by which we provide multiple mechanisms by they can do this, at a much more faster way. And then customers are actually looking out for something like this as well.
Makes sense.
This is by the way, guys, this is such an interesting and larger topic. I'll just throw one challenge out to you guys, because I've been thinking about this problem in the context of what Tanmai derisively called OLAP, which I will ask him to withdraw, but more about data around data lakes, analytics, OLAP warehouses, right? Two comments. So if I put my Silicon Valley blinkered hat on, what I'm hearing, which is really interesting, is in the data lake side, where the diversity of data is much higher than the online side, where you guys are operating. I'm now hearing interesting stuff from my friends at Facebook, Airbnb, LinkedIn, is that you will have you have your log data and your third-party data and your Salesforce data and your customer data all coming into your data lake, but they also want to provide access through GraphQL APIs to like domain objects which are on the online side. That is so interesting. I think the challenge I'll throw at you guys is, I think the governance tier on top of data lakes is actually a lot more complicated. Search and discovery is also a problem, but I think the diversity of data is a lot more. For example, there are like pipelines there, right? Data pipelines are like a first-class object. But what GraphQL is enabling us to do for us SQL old-timers is that it's a much more elegant and higher level and declarative domain modeling language, which is very popular today on the online side, which is why we're having this conference, right? And I suspect that GraphQL so there will be a two-tiered metadata system that might even be coming into being on the offline side above data lakes, where your GraphQL metadata object tier will also become accessible there, but for more compute heavy, for more analytics queries. But I feel like the governance questions you guys asked, I completely agree that I think it has to be thought through a lot more on the online side. But if you look at the data lake side, it's actually an even richer problem. Governance, like the metadata is a richer problem. And I feel the GraphQL domain model part will be a subset of that. But there is it's really exciting to see how the offline and online data systems are going to feed off of each other. And parts of it will converge, but parts of it around security, around diversity, will actually require, I think, new innovation. So I think it's super exciting.
Absolutely. So let's dive in a little bit more to governance of what, and let's think about federating passive data. So your queries, your reads, and then your active data, your data pipelines, events, transactions, all of those. So thinking about these two aspects of data and data federation. Tanmai, you want to leave that one off?
Yeah. No, that's a good segue into the into kind of the separation where whenever we talk about GraphQL, right, it's almost as if the entire world, all of us together, we only think about query, because all of the examples of GraphQL are like query, curly brace, and then this beautiful JSON thing that you can query, right? And it's really nice. And we're all focused on like query data, get data from everywhere, right? But there's this also other aspect of working with an API, which is the mutations, or like when you're executing something, right? And and that's where I think things become kind of interesting / challenging, right? Because or how we think about them. Like, for example, the way that we've thought about it at the way that we're thinking about it at Hasura is that we're saying, we should, when we think about the read side, right? What we want to do on the reads is solve kind of those two problems that we were discussing, that Dan and I were discussing before, which was that aspect of there is a protocol matching that needs to happen, right? Where two systems need to meet, which is there's a basically saying we want the JSONification of whatever is there, right? When we're reading data, we want that's the problem that we want to solve is JSONify everything. And the second problem that we want to solve is governance, that we want governance on everything that we've JSONified. And that is kind of the read story, right? When we think about the write story, it gets more complicated, right? Because if you look at the GraphQL spec and we look at GraphQL mutations, what do you even mean by federated mutations, right? What does that mean? It's not when things are a REST endpoint, that makes sense. You're like, let's call this endpoint. It'll go do something, and then it'll tell me if it's successful or not, right? Makes sense. When you think about a mutation, you open up a GraphQL mutation and you say GraphQL mutation, curly brace, right? And then you say action 1, action 2, action 3. So you've made one API call, and you've fired off 3 actions in the same mutation block. Now, what does this mean? Does this mean that the GraphQL, the layer that is doing GraphQL federation, is going to do a distributed transaction, is going to execute them one by one, right? And the GraphQL spec says that, well, we'll try to execute each of those actions. And if we see a failure, then the first 2 have succeeded, that's fine. Third is an error. That's the response that you get, which is a specification, right? Which is fine, which is an opinion. But that might not necessarily be what is easiest for developers, because as a developer, I like an API because it gives me all or nothing semantics. I don't want things in the middle, right? I want to make an API call and I want it to work or not work. I don't want to deal with the fallout of what happens if part of that API succeeded or not. right? And so that's kind of a challenge, right? And I think like so that's kind of one part of the challenge. And I think the other kind of closely related thing to that is that if we think about moving towards driving things with events, increasingly we're driving all of our writes and we're moving away from kind of transactions on one system, right? Like API consumer, monolithic API, single database, everything is a transaction, everything's easy, you get single APIs do transactions with the asset database, right? That's a nice world. Now we're moving to this world where there's 1,000 microservices. I'm still like, I think my ears will bleed or something. 1,000 microservices is insane, right? So you have 1,000 microservices and you have a bunch of actions and APIs that need to happen across these services. And people are kind of saying that, you know what we'll do? We'll drive it through events. We'll run an event will go do something, right? That'll fire off an event, go do something. That'll fire off an event, that'll go do something, right? And so what's kind of the federation story here, right? Like, is it valid to say that an important aspect of data federation is event federation, like the workflow engine story and the innovations that are happening in workflow engines across cloud vendors and across in the open source ecosystem as well? And that is, I think, something very interesting to think about. I would love to hear. I mean, obviously, like kind of a historical thing from BG on like what were write federations like? How were people thinking about distributed transactions? And then from Diane on, like when you're bringing that GraphQL API, how do you handle that mutation problem, or like is it not a problem? But those, sorry.
I think you've touched upon a lot of different things. I think I'd like to separate them out, right? I would say the SERD problem of JSON or protobuf is a different problem. You have to do SERD somewhere. Let's ignore that for now. By the way, Tanmai, my kids who are watching this are repeatedly asking you why you're calling out my age, but I'm going to pick on you later. I'm getting heavy back chatter here. And thanks a lot, by the way. Okay, so let's separate the data model part out. I think that's decouplable from transactions. Second part is a lot of what Hasura backend is doing, and our friends from what I hear at Airbnb and LinkedIn are building. You guys are all building kind of the new generation, in my mind, of an application server, right? Where you will support events and active pipelines and kind of, point reads and complex application logic there. I think I would even separate that out from what transactionality are you going to offer? What level of ACID will you offer? Will you offer like serializable, like all this stuff like committed, read committed, this and that, all the stuff that we had to deal with back in the OLTP side. I don't know the answer, but I would say supporting like two-phase commit and distributed transactions, it doesn't look like good design taste. My suspicion, and I'm going to be proven wrong here probably, is my suspicion is what do the application programmers really want who are building on top of microservices? Do they really want to do multi-database inserts or updates? I would be surprised. I would guess most of them want one source of truth that you want to finally do a commit to, but that you'll do a lot of annotation like reads from other sources, whether the sources are services, right? That's my suspicion, right? Because ultimately, if I looked at everything I've discussed with you also, Tanmai, a lot of the stuff on remote side is basically for annotations or for most active data that you got back. Then you say, I'll go store this in a single backend. So I suspect you guys will have to support simpler transaction semantics and not make lives very complicated for application developers. Yeah. And you'll have to push a lot of did the write get committed or not? Is there going to be a rollback? Are the replicas? Yeah. I would suspect you guys have to push that responsibility down to the database tier. So this is like
it where it should be. Yeah, that
right. I mean, I would strongly. I'll just end with one thing. If you go back to again kind of the old timers and you go read like old papers coming out of IBM DB2 and Oracle, the whole application development part was enormously difficult because you had to decide what guarantees to offer, and a lot of different flavors were offered there because you couldn't just say, oh, you will only do one kind of transactionality level. I suspect in the online point read and point write world, maybe you guys don't need that level of richness in transaction level. So I might be proven wrong, but I would highly recommend for folks like you guys who are building application servers now and deciding what semantics to give the application developers, you guys should be thinking about this now. So super exciting. So I don't have a solution in mind, but I can always raise questions.
Yeah. Just to quickly add on to that, I think like this idea of saying that you trigger off a workflow that does something and then updates a central source of truth or some set of sources of truth that you can read from, right? It's kind of like that command and query pattern. And I really like that. And I think that's what's happening. Like we're all organically moving to, because we can't deal with this 2PC problem, right? It's ridiculous. Like nobody's going to build application servers that do 2PC with each other, right? Like what, send an email, then roll back sending an email. That doesn't make sense. So this CQRS thing is naturally emerging, right? This command and query style of thinking about it naturally emerges. And I think that fits in well into the GraphQL style, because you expect a mutation to map to some kind of a command, triggers off a workflow, which then goes and updates your read stores, right? And then you do, as long as you have read after write semantics, you can query from that unified, like that read store and read from that. So you get the benefits of GraphQL where you say, I did a point transaction, I get a nice like read thing. So that makes a lot of sense. Yeah.
Yeah, and what I've heard in this, there's actually a few interesting things in particular. So first is like, you're right, like GraphQL and a lot of use cases kind of read heavy, but even in read kind of operations and query, if you have a partial error or like partial response and partial error, this is like a whole level of complexity that's currently pushed down to the client side, because like in the simpler world, right, this is way more atomic, the thing either happened or not. Here it's like you can get partial response. And if you add the mutation on top of it, this gets like way more intense and complicated. So I agree, in case of read, there is a way, or queries, there is a way, I guess, more incentive to like kind of like write some kind of infrastructure around it that is allowed to like parse the errors of things like that. But in terms of mutation, I would also encourage like myself and anyone who's using GraphQL as an interface to go simple and do not try to commit in a single mutation to multiple sources. That sounds a bit.
Can I ask you a very quick question, Diana and Tanmay and Deep? So today, since I don't write complex GraphQL applications, like, do you actually have to do like defensive programming there when if you do a read from a remote source, or you do even a write, maybe the write into a single destination is easy, but when you do reads from remote sources, do you actually have to write a lot of like timeout, error handling, all of that stuff as part of your application, or will that be handled by the application server? I'm just curious.
Oh, that's a loaded question. So let me just answer.
Okay, I didn't mean to ask a loaded question. I actually honestly, I thought these are all interesting trade-offs. That's why.
I mean, just like in general, right? The timeout or like things like that, like some of it, and there's a few layers, right? So I will talk about BFF, backend for front end. There's a client, and then there's the rest of things that I don't talk about. So like, there's a lot of stuff that gets kind of hidden behind like this backend for front end or the GraphQL layer, pretty much. But on the client, I think that's important stuff. That's what like front-end engineers are excited about. They sort of can assume the data in a certain shape to come in their way. Although the caveat is that probably a lot of this can kind of be nullable kind of thing. The object may not come back at all. And that's like, you sort of build it into the whole client logic that anything that you asked for, like there's no guarantee for it to come back pretty much. That's the story.
I see.
Yeah, and I think to add to that in terms of like in specifically that with respect to the failure handling and the circuit breaking, right? Like that's stuff that we have to do. Like, because I mean, like that's the stuff that we try to take care of at Hasura, right? When we're saying that we want to provide a GraphQL API with like that metadata store that connects to these different sources. You can now unify them across different protocols, whatever. Then I think the the piece that we also have to take care of is what like traditional gateways have to do in terms of like HA, failover, if this fails, right, what should be done, returning nulls and then returning an error associated with it, right? That has to be done by this thing, right? Because it's behaving like a gateway. So there is some element of that needs to be done. So wherever that GraphQL service is, and it has to integrate with the error mechanisms of the upstream source, right? So if you're talking to an upstream source that has a particular way of doing a failover, do you assume that the upstream source is actually fronted by another load balancer that takes care of the failover? Right? Like, for example, I'm talking to a set of microservices, but going through a Kubernetes service, and the Kubernetes service is doing the failover for me. If I can assume that, then I don't need to do too much work, right? Then we can just say we'll try it. If it fails, it fails. But if this service has to handle the failover, like for example, if you're talking to databases where you might need to explicitly handle the failover, right? Or especially for distributed databases, the topology of the databases needs to be known, right? So you need to handle that explicitly. So you need to say, I need to query this shard. This is like the best shard to query. But if I don't like the shard, I'll query that shard, right? So there are those layers that need to exist, whether they get collapsed at the gateway or whether you'll have another service that takes care of that. There's lots of thoughts there that need to be thought about, I guess.
And also, Tanmai, I think this is also very use case specific, right? I mean, whatever the whole architecture completely depends on what kind of use case you really have.
Yeah, Deep, can you say a little bit more about kind of what your teams have been seeing and how they've been approaching this?
Yeah, I mean, so I've seen a lot of CQRS, into implementation, and mostly I've seen, right, I mean, that the write channels and the read channels are completely separated. So mostly enterprise customers today, right, they understand the value of GraphQL. They understand, how GraphQL can actually make their life easy when it comes to read queries, right? And that's where, they want to keep their, good old write queries outside completely as a separate channel, and then create sort of cache on top of the DBs itself, where, from where they can query. Right? I mean, that has been, let's say, one of the very, very preferred approaches by customers as well. And actually, if you see, right, I mean, that gives them the value of GraphQL, right, at a very short amount of time. And it is also forward compatible. I mean, today they do not really need the capability to have a GraphQL API for write queries. But in future, if they have a requirement, well, they are just one step away.
This is super interesting. Deep, quick question. You mentioned the cache. That's so interesting. Who is in charge of maintaining the cache and refreshing it?
Exactly. I mean, that's a real challenge in the whole CQRS story, right? I mean, if you see the whole digital hub, integration hub story, that's also the pain point. But then, I mean, this is completely, I would say, very, very use case dependent as well, right? I mean, I've seen several use cases where it is the owners of, let's say, the middleware itself, right, who takes care of making sure that the cache is well properly set up, has all the latest data is up to date and synced perfectly with the backends as well, right? But then there has been instances where there is a event bus, right, which takes care of all the events that comes in, and then the cache is automatically, let's say, gets synced on the events that flows. I mean, that is I would say, I mean, most of the times I've seen that this is completely dependent on whatever the architecture or whatever the background use cases are.
But the caches are read only, correct?
The caches are
stored, right?
No, the caches are completely read only. As I said, right, I mean, customers would usually already have a channel for write, so they do not want to disturb the write channels.
Gotcha.
Right? For them, the write is there.
Right, but you're saying the application server has to make sure that the cache is updated.
Absolutely.
And that
Absolutely.
the comes in and stuff. Okay.
Yeah.
Wow, I see. Okay. Thank you.
That's so cool. All right, so we have time for one more lightning round. And kind of what I want to ask about is, what interesting trends are you seeing with data federation right now, and exciting things that you think people are working on and you're looking forward to seeing new advances with? Diana, you want to lead off?
Well, I want to say that what I'm seeing exciting is that people from microservices kind of background recognize the need for it, because I do believe at some point there was a notion that microservices it's sort of the solution to the scale and the growth. And I finally see in the industry that people recognize when they need to build this consistent data model, which is distributed. And because of that, there's a lot of interesting development happens. So yeah.
Very cool. Dee?
How I see it is that, tomorrow integrations are going to be free. I mean, today it costs for you to have a well integrated enterprise, right? But then tomorrow your integrations are going to be completely free, because that's how the systems are going to talk, right? And if you see today, the whole landscape is completely integrated, if you see, right? And the latest trends, I would suggest that the events are in, right? And then there's a one metadata model that's going to come up as well, where the idea is that you do not need to describe your payloads in the form of protobuf or in the form of JSON. You have one mechanism, one payload mechanism by where you have a common data object model, right, from where you describe your payload. And then based on your need, you can directly convert those payloads within the choice of your protocols. Really, this could be Thrift, this could be protobuf, whatever be the mechanism, really.
That's really cool. Yeah. All right. And BG?
I'll throw a couple of challenges out to you guys. One is, I'm going to make a bet, and I'm probably going to be wrong, that if you look at the impact of GraphQL on the data lake side, I'm super interested in what can happen there. My suspicion is, and that's the challenge, is metadata management on that side will have to be a much larger story and more independent, and GraphQL will form part of it. Happy to be proven wrong. I think the interesting thing from hearing what I heard in the last hour from you guys, coming back to the online side, is if you look at the history of application design on databases, a lot of thoughtfulness had to be put into the data model itself, right? Because you have to pick schemas like Snowflake and Star and so on and so forth, right? You have to decide where to build the indexes. What I haven't heard, like GraphQL essentially absolves the application programmer from a lot of responsibilities, basically says all data element is created equal. That's how I felt reading the documentation. I might be wrong. I think what I haven't yet, I suspect, if I just say that history kind of repeats itself, I suspect that the whole domain, the whole modeling aspect, that there will be a back and forth, because ultimately GraphQL metadata tier, the domain model tier, will sit on top of some highly optimized online source of truth databases, right? That's the really hard part. Because all this remote stuff is mostly for reads, right? As Deep already pointed out, what I haven't heard yet, and maybe in 2 years we'll do the same panel and we'll kind of look back, is I suspect, like, if you look at the whole history of both transaction guarantees, application design with transaction guarantees, and the data model needs for transactional systems versus, say, warehousing and OLAP systems, there's very deep work that had to be done about what gets solved where and when. And I haven't yet heard, like, you guys are ultimately going to make the GraphQL-enabled applications more and more complex, because you're allowing tremendous amount of diversity to be accessed in terms of sources of data. And you want it online. What I haven't yet heard is there going to be a methodology for domain modeling in the application tier also, in the same way that we had to do it like in the last 50 years, essentially? Or are you going to push everything down to database design? Because I suspect that it has to be a back and forth. And that I will leave that as an interesting open problem that I'd love to hear from you guys in a few years going through it. Anyway, so my questions are more about kind of which parts of history will be repeated, but more interesting, which parts don't need to be repeated and something new will happen. Anyway, that's my non-answer and more in the form of question.
Yeah, I think the piece of the GraphQL thing that this data federation and GraphQL and all of it coming together, I think I'm super excited about the conversations that this has forced all of us to have, the entire ecosystem and the community around what is the point of all of the work that we're doing, right? It's saying that ultimately there is data in places and there's people who want to do stuff with that data and write code. And those are the two most important things. Everything else in the middle is detail, right? Whether it's service, protobuf, GraphQL client, whether it's database client, right? Whatever it is all detail, and it's forcing us to kind of think about these things and have these conversations and figure out like what is the best place to abstract things away once and for all, so that there are the least possible things to worry about, the least possible number of things to worry about, right? That's kind of what it's forcing us to do. It's forcing us to say, like, we are on a path as an industry to kind of increase complexity everywhere, right? How are we going to manage that complexity? Which part is going to be automated? Which part is going to be taken care of? And which part of it are people actually going to do themselves, right? And I think that is that conversation that is starting to happen around this. And I think there's different kinds of solutions that are emerging. And there's lots of different ways of doing it, especially in the GraphQL ecosystem, but also outside the GraphQL ecosystem. So I think that's kind of what I'm excited about. This overall story of developers kind of getting enabled, which is kind of where it all should be. Everything else is detail.
Definitely. It is very exciting. And yeah, I think we are about ready to head out to a quick break. And then we'll get going. Thank you very much to all of the panelists today for coming out. Super appreciate it. I've learned so much and looking forward to continuing the conversation.